Lesson 115, students. I'll start you off here with, you can just skip number one. Now, how's that? That sounds like a teacher that has heart. Skip number one. That is from lesson 114. Okay, skip number one, and we will go to number two. And this is from your yesterday's lesson. Actually not, it's from lesson 113. Ratios, here we go. Pressure varies inversely as the volume. Let's just review just a moment quickly. Inversely, and what's the other word? We have two different kinds of problems on these. Problems, way of solving these, inversely and directly. Do you remember this? So we look for those key words, inversely and directly. We'll do a few of both of these. Here we go. Number two, pressure varies inversely, and that is a problem that is set up similar to this, where we have, and remember this is always your constant. We use that K as denoting the constant number. That's the type of problem. It says that pressure varies inversely as the volume. When the pressure is 10 pascals, the volume is 150 liters. Again, just for a quick, simple setup here, we remember we always use the big number first. 150 equals, it's 150 liters. I should put the liters here, I guess. 150 liters equals 10. Put the 10 here because we know this is a K. Now we solve for this. What would make this equation true? 150, 10 divided by, what number divided by 10 equals 150? Is this right? 1500 divided by 10 equals 150. This is your K. What do we say about the K? One more time. The K, the constant, never changes. So we will, once we establish that 1500, we will leave that there for now. Now they're asking us to fill in something. What would be the volume if the pressure is reduced to 3 pascals? This was pascals, so we'll reduce this to 3. Now we need to make this equation true, so this is our number. We cannot change to 1500, we must change this one. 1500 divided by 3 is, are you with me? It is 500 liters, and there is your answer. That's number two. Number three is the same type. Again, this varies how? It varies inversely, so we have two of the same. Attractiveness varies inversely with the wiggles. Okay, then the two numbers are 310. The big number always goes first. 300 equals, and we put the K always goes in this position, and we have the 10. What would the attractiveness be at 150 wiggles? Here we have 300 wiggles, and we will change this number. Well, first off, let's get the K, I'm sorry. What is the K here? What would make this equation true? Is this right? This is a 3,000. 3,000 divided by 10 equals 300. This is a K, it never changes. And now they're asking us to change the wiggles. This is a wiggle, so we would change this wiggles to 150. Now we must make this equation true, and we will not change to 3,000 because that is our constant. What would we change if we need to change this number? 3,000 divided by 150, is that 20? I'm sorry, I'll verify that with my calculator. 3,000 divided by 20 equals 150, that is correct. So your new number is 20, and it is 20 what? What's the label? Well, we don't need to put the label. Okay, that's number 3. Number 7. Number 7, 8, and 9 are the new things for today. Let's just look at these. Y, X, that's the first one, that's number 7. Number 8 is Y, x plus 1, and number 9 is x negative 5. 7, 8, and 9, and we need to have your graphs. Hopefully you still have some graphs on a sheet that Mr. Troy gave you. If not, you'll have to go back and find one from a previous lessons. You're actually going to need 3 of those. The way what we do here, let's see if we can help you understand this. Basically, we could. Let me see if does this make sense. This is the same as if we would use this as an equal to start with. Y equals x. In the equation, how would you do this on the graph? This has no number, so we would start off on the 0. Do you agree with that? And now this there's no number in front of this, but so that's understood to be a 1, so it's a 1 over 1. We can count a bunch, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And it is going uphill, so we did that right. Here is our graph. Now we go down to this, so y is greater than x. We will shade out the side that is greater. How are we going to know if it's greater? There's 2 ways. Greater is usually in the positive, so we are going to positive. Now what we need to do though is check ourselves, and they're saying the way to check it is pick out any set of points in this particular side or that side and see which one actually works. I'm just going to choose, let's choose something over here in this line. I'll just choose this point right here. And if you're with me, this would be a 3 and a negative 2. Is that right? This point right here. And that's on, that would be I just picked out anything on this side over here. Let's see if this equation is true. 3 is your x and negative 2 is your y. Now let's try this. Fill this in right here. Here it says y is greater than this. So I'm going to put negative 2 and 3. Is this a true statement that negative 2 is greater than 3? You think you'll agree with that. It's a very false statement. So that did not work. Anything on this side was not a true statement. Now let's try anything over on this side. Let's try a 3 and a 3. That's going to be a negative 3 on the x line and a positive 3 on the y line. Let's see if this works. Here's our 3. This is negative 3. Is this a true statement that 3 is greater than negative 3? Absolutely a true statement. So what we know is this is the side that is greater. So we will actually, on your graph, you will shade this whole amount on this side. Everything up in here works with this y is greater than x. Kind of a lot to remember. Let's try another one. That was that one. This one is from here to here. I don't need absolute values. I'm just trying to divide it here. But y, again, let's take this, move this down, and let's just first off solve it as an equal. Y is 1x positive 1. So let's start off on positive 1. And this again is a 1 over 1. We can go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right here. We're coming down across here like this. I want you to do it with a nice straight edge rather than freehand like I'm doing. Okay, now we got to make this thing be true. This was our, it says that it is less than, y is less than or equal to. Y is less than or equal to. So which side do we shade? Again, we can just pick out on either side, which side do we shade to make this true? let's go up in here. So now I have a 3 and a 2. We'll put the 2 right here and the 3 under the x. What I have here is 2 is less than or equal to 3 plus 1 is 4. Is that a true statement? 2 is less than or equal to 4. It is. So I picked out the right side. Let's try it on this side. We'll just try this up in here. I want this to become so you understand it. Let's pick out something. Oh, let's try this right here. So I have 2 on the x line and 1, 2, 3, 4, 5 on the y line. All right, so I put 5 and 2 where the x is at. So 5 is less than or equal to 3. Is that a true statement? That is not a true statement. So that is, we must shade in this side. Okay, that is where we solve for number 8. And the final one, we'll move it over here, x negative 5. That's number 9. This one's in a simple form. Where is negative 5 on the x line? This is our x line. We go over here to negative 5. 1, 2, 3, 4, 5, right here. And we draw a line down everything from here. Which side do we shade? This side or that side? If you agree, I think without even checking it out, we can tell that x is less than negative 5, so x is all this side over here. All right. Excuse me, that is number 7, 8, 9. That's your new stuff for today. We'll be working on that in future lessons here too. We go to number 10. Sketch the graph. X plus 1. These are ones that we've been working on before, and this is from lesson 110. Make our homemade graph. This is the same as inclusive marks. If you had it like this, what kind of a graph is x, the square root of x? Do you remember? It's this. Is that correct? All right, and then we have to find where we start off at. This is an inclusive, so this is going to change this to a negative 1. We would choose negative 1 on the x line. Negative 1 to the x line, and we will use this graph, and so it goes up and over like this, starting from negative 1 on the x line. That is number 10. We also have number 11. This was negative x squared. Negative 1 does not have inclusive lines. X squared, what kind of a sketch is that? X squared, I think you'll agree with me, is like this. And we find this on the y line because it does not have inclusive marks, does not have any kind of marks that include. So that we go on the y line, and this is on the negative 1 is going to be right here. And we use this. This also is a negative, so it's upside down. Come across like this. That is number 11. Number 15. Just chose this one because it's a little different than what we've had before. You have to know how to change this around. Let's rewrite that, and then we put this on a number line. If you notice that this is the absolute value of x is less than, let's put this on the other side, and if we change this around, it still is less than. So I took care of that, and then the 4 is on this side. Let's put it on this side. Now what kind of in these 1, 2, 3, 4, 1, 2, 3, 4, -4, -2, 2 and 4. It says that the domain is integers, very important here. And if it's integers, then this is less than, what is the setup? It's less than 4, and the 4 here, and then it's the integers all the way through. So we do just the integers. That is the way you solve number 15. Now number 18. 18 is a multiplication. Just doing one of these, just so you continue to learn how to do these. This is a 2, -4, square root of 3. Multiplication. Let's begin here. 2 times 4 is 8. 2 times 1 is a positive 2 to the square root of 3. This is a -16 to the square root of 3. And this is -4 to the square root of 3 times 3 is 9. Add these together. 8, -14 to the square root of 3. And this can be solved by the square root of 9 is a 3, so a -4 times a 3 is a -12. So combine these two numbers together, that's a -4, and this one is just like it is, -14 to the square root of 3. That was number 18, and we have one more. Number 26. I'll just put up here the different A. The solution to A is A equals -1, -1, X equals -2, and Y equals, is that -5, correct? And then we will, and please take your time on this, and there's a lot to solve here. Fill in the numbers. The A's are, here is, this is A, this is -1. And this is -1. X's is a -2 here. And we have 1, 2, 3 Y's. Y is a -5. -5, -5, and -5. Sure what I did here. This is not supposed to have a that all right? So we'll solve right here. We have a break here, so we can solve what's on this side. -2 times -5 is a +10. And here's another break, so we have an opposite of -1 is a +1. And now we are ready to solve this. This is a -5 times a -1 is a 5. And then it's the opposite of 5 is a -5. And that's right beside this, so let's solve for this next. The opposite of negative 1 is a positive 1, and negative 5 and a positive 1 is a negative 4. So we have a negative 4 times a negative 5, that is a positive 20. Positive 20, pull these two down, positive 10 and a positive 1. 10, 1, and 20, that is a positive 31. If you take your time, you can follow all the way through, and not any small mistake changes the whole number. That was number 26. Very well, that concludes lesson 115. I'm excited about finishing this course up. I'm sure you are too. It's been a lot of learning. We've learned a tremendous lot. There is so much to learn in that textbook, and we're coming to the end. Just have a few more pages left and we will be through. Keep your heads up and stay positive, and we can finish out with a sprint. God bless your day.